Okay, in this video, we are going to be simplifying these exponential expressions. So these are bigger problems than I've shown you before. Now, it's super important that you have watched the other videos about the quotient rule, the power rule, the product rule, because if not, this is not really going to make much sense to you at all if you haven't already watched those, because with the problems in this video, we're going to be using more than one rule for the same problem, okay? And I'm just going to kind of walk you through it and not necessarily explain each individual rule again. We're just going to kind of work through the problem together, okay? So let's look at number one. You have u cubed times v squared, all of that times uv squared raised to the third power, okay? So the first thing I see and what I want you to look at is I want you to look at this second part of the expression. Notice that we have parentheses, and kind of like orders of operation, we need to get rid of those parentheses first. Okay, so there's the power rule that says when there's a 3 on the outside that we can multiply it to the other exponents. So this expression, and I'm just going to write it right below, is going to be u cubed times v6. Okay. The first part of the expression, we didn't really have to change at all. I'm just going to move it down so it's on the same line. Okay. A little crooked, but it works. Okay, so the product rule says that when the base numbers are the same, we can add the exponents. And so right here we have our base of u. 3 plus 3 is 6. And then we have our base of v, and then 2 plus 6 is 8. So your final answer for this problem is u to the 6th power times v to the 8th power. Okay, so take a look at this one. This one automatically probably looks more complicated because it's in a fraction format. So what we're going to do, the best way to tackle a problem like this is to start working with the numerator first. And especially since the numerator has two separate parts, we want to make those two separate parts together into one. And then we can start simplifying with the denominator. Okay, so what we're going to do first, because all of these are just being multiplied, we can use that product rule again. Okay, the coefficients, the 2 and the 3, will multiply to get 6. Okay, we do need to keep the letters in alphabetical order, so even though there is not an x in this first expression, we still need to write the x from the second one. And then y cubed times y cubed is y to the 6th power. And then I'm just going to move this same denominator over. All right, now we're ready for the second part. We have it down to one expression over another expression. And so this is when we can use the quotient rule. The quotient rule says we're going to just simplify these coefficients, these whole numbers. Put our answer down here. So this is 2 over 1. Okay. Right here, the x would really have a 1 right here. And so 1 take away 2 is -1, but then to convert that -1 to a positive, it's going to go down to the bottom. So hopefully I didn't do that too fast. There's 2 x terms in the bottom and only 1 in the top, so we could cancel one of the x terms out and leave 1 left over. Here we have y to the 6th over y to the 4th, so we can kind of cancel out 4 of the y's, and that leaves 2 of the y's left over. So your final answer is 2y squared over 1x, or you can erase that 1 and just have it over x. Okay guys, let's do 2 more examples together. Take a look at example 3. It's 2m cubed over n to the 5th, all of that raised to this negative 2 power, okay? So I want to just show you, just to kind of give you a visual, what that means when it's raised to negative 2, when it's a fraction in here, is it really means that this entire numerator, 2m cubed, is being raised to the negative 2 power, and n to the 5th is being raised to the negative 2 power. So you can think of it now as separate problems, just solving the numerator and solving the denominator. Okay, so what we're going to do is we're going to apply this power rule, okay, and so it's going to look something like this. It's now going to be 2, which is our coefficient, raised to the negative 2 power, and m was cubed, and so 3 times negative 2 is negative 6. All of that over n to the negative 10. Okay, so we have a lot of negative exponents, and really, if you haven't watched this negative exponent video, I really want you to find it and take a look at it. Basically, the short of it is that when you have a negative exponent, it's improper, and in order to make it proper, it's an opposite operation happens, okay? Negative turns to positive, and those are opposite ends of each other. And so without going into too much detail that the other video covers, it basically means in order to make this numerator have positive positive exponents, that whole numerator is going to go down to the denominator. And then whatever is negative in the denominator is going to go up to the numerator. And that switching process of moving opposite, it is the basis of the negative exponents, just to kind of save us time. So right here, 2 squared is actually 4. So the 4 is going to go down to the bottom because it was raised to the negative 2. And so is the 6. The m to the negative 6. When it's changed to the bottom, the negative goes away. Okay, and then we're going to put the n to the 10th power, and again, we're going to get rid of the negative, but we're going to write that up in the numerator. Okay. Okay, last problem that I'm going to work through with you on this video. We have another one set up, like a fraction. We have x to the negative 3rd raised to the 4th power times x to the 4th. And all of that over 2x raised to the negative 3 power. So we have some more negatives in here. The first thing I want you to do again is to focus on this numerator. Right here, we can use the power rule. So this is now x to the negative 12, and then times x to the 4. Our denominator is going to stay the same for right now. Okay. One more thing before we start working with our denominator, we're now going to use the product rule to combine these two together. It says we can just add the exponents if the bases are the same, which they are. So negative 12 plus 4 is negative 8. Okay. Now we're going to use the quotient rule. That says, again, when the bases are the same, that both of them are x's, we can subtract these two exponents. So over here we have negative 8 take away negative 3. So negative 8, let me write that down somewhere. Negative 8 take away negative 3, which would be a negative 5. And that answer stays in the numerator. And then the 2 stays, our coefficient stays, because it doesn't have an exponent at all, so it just stays. However, same thing again, right here, this negative exponent is considered improper, and to switch that, we're going to do the opposite. Instead of having it in the numerator, it's going to go down to the denominator. So it's going to be 2x to the 5th. Okay, and what I say in class is if your entire numerator has disappeared and everything is down in the denominator, you still need one person to stand on top of that fraction bar so that that denominator doesn't get loose and come up to the top. Okay, so this is 1 over 2x to the 5th. Now I want you to pause the video and try some of these examples on your own.